Okay, so we have this equation. And all I asked you to do with the equation at this point is just factor the left-hand side. And of course, nobody had any trouble with that. Move it over a little bit. Okay. So we factor this to x plus 5 times x plus 1 equals 0. Agree? Okay. Now, how do we solve this equation? Well, let me just ask. Can you give me a number which, if plugged into that equation, gives you 0? Okay, I asked, did anybody tell me the value of x that would make this equation true? The number you could put in for x that would make this so. And I observed, well, okay, what about x equals 2? Well, if x equals 2, this is going to be 7, and this is going to be 3. And 7 times 3, you don't have to multiply it out. You know it isn't 0. Okay? And if x equals -7, you'd have -2, -6. Well, -2 times -6 isn't 0. You don't have to multiply it out to tell. Okay? X equals 3,483. Okay? Then x plus 5 would be 3,848. That'd be 3,844. Okay? I think that's right. I'm forgetting my numbers already, but you don't need to multiply those numbers out to know that it's 0. It's not 0. That's not a solution. Okay, well, then ask, what if x equals -5? Well, if x equals -5, then this is 0. And this is -4. And what's 0 times -4? It's 0. Okay. So if this is 0, the whole thing is 0 because you're multiplying. 0 times -4 gives you 0. You don't have to multiply it out. You know that. What other value of x would give you 0? Okay, so if x is -1, you get 0 here. It doesn't matter what you get here. Well, it's going to be 4, but it doesn't matter at all what this is. If this is 0, the whole thing's automatically 0. Okay, that's very important. Okay, so what we've established is x is -5, we get 0 times -4 equals 0, which is true. So x equals -5 is a solution to the equation. Now, we're going into a lot of detail there, but if x equals -1, we get 4 times 0 equals 0. So -1 is another solution. All right, well, X equals 3, we get 3 plus 5 is 8. X plus 1 is 4. Eight times 4 equals 0. It's not so. Thus, 3 isn't a solution. X equals 231.7. That's one of my favorite numbers. Let's see if that's a solution, okay? X equals 231.7. We get 239.7 multiplied by 234.7 equals 0. We don't need to multiply these. To know that that ain't 0. It's not 0. Why? Because the only way you can get 0 is to multiply is for one of the numbers to be 0. Okay. I'm going to say the only way I'm going to wait for the product to be 0 is for one or both numbers to be 0. So -1 and -5 are the only solutions. Make sense? Okay. And yeah, seems visible there. Okay, well, that's called the 0 property of multiplication. So, make myself much room here, but I'm teasing part of this structural right. Sorry, I had to squeeze that in. I should have anticipated it. But this is a 0 property of multiplication. And you will read that if you read your text. Okay, so again, we're going to solve this equation using the 0 property of multiplication. So the logic is this: x plus 5 times x plus 1 is 0. a zero property multiplication, x plus 5 equals 0, or x plus 1 equals 0. Okay. I didn't say x plus 5 equals 0 and x plus 1 equals 0 because it can't be both. If x plus 5 is 0, that ain't. And if x plus 1 is 0, this isn't 0. Okay? It's or. And we want to write out that or. Okay? Make sense? Okay, well, that's pretty simple. Now we're going to abbreviate it a little more. In parentheses there, I've got ZP for the zero property. Got room, you could write it out, but by the zero property, this breaks down to this. This equation is totally equivalent to this. Okay? I'll write out the step in solving this, although it's an obvious step. Okay, that's more abbreviated. I would recommend writing this step out anytime it isn't just x plus something or x minus something. Okay? And we can check. Well, that checks -5, and then we check -4, and -1, sorry. Okay. Well, the equation, this thing can get a little more complicated. Let's say it's okay. Go ahead and solve that. Writing it out, well, I've written it out here. Write out every step, including the or and the little lines and everything else. Okay. Well, this equation then breaks into two equations. Did you write ZP? You didn't. You didn't do everything that I did here. I think you did everything else. Okay, and wrote it out in good form. But let's make sure we remind ourselves that there's this thing called the zero property and think about what that means every time we do it, so that we internalize the idea of the zero property. Okay, so we have 3x minus 7 equals 0, or 4x plus 3 equals 0. Okay, we'll solve this equation. Three x minus 7, we add 7 to both sides. We get 3x equals 7. 3x over 3 equals 7 over 3. So x equals 7 over 3. Now, as I said, I want to see that or in every step because we really want to emphasize that this is an or. Because when we write out our solution set, we say the solution set is this and this, because these are the solutions, okay? This is a solution and this is a solution, okay? It's not this is a solution or this is a solution. Difference between and or is a little more subtle than most people take it for. Okay, so we do 4x plus 3 minus 3 equals 0 minus 3. And it's obvious what these steps are, but we do want to write them out. Okay, so there are our solutions. Okay, this is a solution or this is a solution. They can't both be solutions. However, when we write out our solution set, this is in the solution set, and this is in the solution set. Okay, because each of these is in the solution set. Therefore, this is in the solution set for sure. And this is in the solution set. They're different because the solutions were this or this, or the logic of the solution told us this is a solution or this is a solution, indicating they can't both be a solution at the same time. Now, if we had 3x minus 7 times 3x minus 7, the same thing, we would still write out 3x minus 7 equals 0 or 3x minus 7 equals 0, okay? But we would notice at the end, oh yeah, they're the same. Then we would say, well, that's a 0 twice. We'd even say that's a 0 of multiplicity 2. That's an important term, multiplicity 2. But, well, I mean, when you take pre-calculus, you'll understand why that's an important term. You probably won't remember it, but you have a vestige of it. As long as you understand all this, it'll give you a good foundation for some stuff that's some of the more challenging stuff in pre-calculus. Okay, there we have it. Let's do another one because this is so much fun. You get to feed up on some easy equations. Let's try x. Okay. I'm going to let you see what you can do with that one. And I'll say there's something that most people miss when they do this one. So let's see how this works out. Okay, so we do this. Well, how can this be 0? But one thing that people often miss is certainly if x is 0, the whole thing is 0, right? Because you're going to multiply 0 by whatever numbers you get here. Those numbers would be 2 and negative 31, but it doesn't matter what they are. As soon as x is 0, the whole product is 0. So that's a solution. Or x plus 2 equals 0. 5x minus 31 equals 0. Okay, so we and solve that. Well, x equals 0 is already done. This gives us x equals -2 equals -2. But since we've got the ors in here, we're going to just write them all. It's a little extra writing, and we eventually will dispense with it, but I do recommend that we do this. And I'll put 3 dots here. Well, yeah, let's do it. No, I don't want to do all that. Okay, or x equals 31/5, because the solution to this was obvious. Make sense? Okay. So the solution set (0), -2, and 31/5 are all solutions. Then you would want to check. Okay. Well, I'm going to write another equation. Okay, this equation isn't factored for you. So here's where you need to factor it. So let's see if you can factor that equation. Okay, well, okay, here we have it. We're gonna have to factor this. You have to put it into factored form, kind of like the ones we've been seeing. So what I'm gonna do is I'm gonna write this as, first of all, x times 5x squared minus 21x minus 62. Okay. Then we have that algorithm where we multiply this by this and do all the stuff we do. Okay. I'm not going to go through that. But I'm just going to say that this factors into x times x plus 2 times 5x minus 3 equals 0. So this is just a quadratic. You have an algorithm for factoring it. And if you follow the algorithm, it'll do this. Okay. I'll tell you right away off the top, but just, I want you to know there's an algorithm. I want you to be able to use it. I'm not going to test you on it. Okay. Because in the real world, we'd almost never have to factor something like that. Okay. So you don't remember the algorithm, you can always list factors. Okay. List possible factors, and it's not hard. It's not that big a list in this case to test. So you do about 8 possibilities and test them all. You'll find the right one. Okay. And that always works. It's just if the numbers have too many factors, it gets really long. You know what we saw last time. You can always fall back on that if you need to, or you can look up the algorithm, refresh your memory of the algorithm. Okay, because you apparently know how to use the algorithm. So there we have it. Okay, so this tells us that, well, this turns out to be the same as this. We don't need to go through the entire solution, but it could look like this, and you could have to factor it. And you know, some of the problems you're going to get, you might want to use the algorithm. And nobody quite got it right, but some people instead of getting x plus 2, they got like 5x plus 10, along with the 5x minus 3. So there's a little glitch with the algorithm. But I wasn't able to see all the details of how some people work through that. Because it kind of scratched over to the side. But again, that should be easy to fix. Now, I'm not going to go through that algorithm again. It's it's worth understanding why the algorithm works. It can take time to show you why it works. And if you really want me to, maybe I will, but we're going to move on to something else here. Okay. Okay, so I'm going to do another one. I'm going to have something here you can't factor. Let's try that one. Okay. Well, we can factor this. First, x times x squared plus x minus 7 is the same as what we have here. So we rewrite the equation. Well, we can try the algorithm for factoring, and it's not going to work. You can't factor this. Now, that doesn't mean it can't be 0. Right, 0 property here, don't forget to do that. You get x equals 0, or x squared plus x minus 7 equals 0. What good does that do you? There's a formula you can use to solve this. And unlike the algorithm for factoring, we're trinomials. They're not that weird, they're just difficult. If you don't remember the algorithm, it gets really tedious. Okay. And as I said, I don't think the algorithm's all that important, but it's important that you learn how to follow it. Okay. So, well, okay, we can use a quadratic formula. Well, there's what it says. It says you got ax squared plus bx plus c equals 0. You look at the number for A, the number for B, the number for C, and you plug it into here, and you plug it into here. Okay? So can you write down what you think the numbers A, B, and C are for this expression? A is the coefficient of x squared. A equals 1. B is the coefficient of x, so B equals 1. And C's the number doesn't have an x on it, so C is -7. Well, I'm going to ask you to plug A equals 1, B equals 1, and C equals -7 into the formulas and see what you get. Okay, so this is pretty straightforward. Now, really, we've got 2 of these, but if you've done this, you've substituted into this and into this. You see that you get all the same numbers. It's just that this one's going to have a plus on it and this one's going to have a minus on it. So we could actually write x equals -b plus or minus the square root of b squared minus 4ac divided by 2a, understanding that this represents 2 different solutions, right? They might not even be different. You could get these 2 solutions would be the same if the thing under this square root sign, this radical, is 0. If this is 0, then the plus or the minus doesn't make any difference. You just get -b over 2a. Okay, well, this one, we get -1 plus or minus the square root of 1 squared minus 4 times 1 times, now you got to be careful because some people wrote 7 instead of -7. You got to be careful about the signs. The reason being, if you aren't, you get something a little bit confusing that we're not really going to talk that much about right now. Well, 4 times -7 is -28, minus -28 is plus 28. Add that to 1 squared, which is 1, you get 29. That's over 2. Now, the square root of 29 is about 5.4. If I add that to -1, I get 4.4. Divide by 2, I get 2.2. But that's approximate, because the square root of 29 is not a number you can write out accurately. is a decimal number. 20, it's 2.2 something. And the something goes on forever. Okay? Your calculator will give you maybe a dozen digits of what the square root of 29 is, but it's not going to give them all to you because they're infinitely many and there's no pattern to them. Okay, anyhow, you have this, and then -1 minus the square root of 29 would be -1 minus 4.4, which is -5.4. So that would be -2.85. For that 5, it's kind of in parentheses with a little question mark. But I believe those would be your two solutions. If you plug into your calculator, and you can check me on that, I could be wrong doing that in my head. And I'm certainly capable of making mistakes. Okay. So if we summarize the solution to this problem, which is all the way over here, we can say that this is the same as x times x squared plus x minus 7 equals 0, which breaks into x equals 0 or x squared plus x minus 7 equals 0. This, by the quadratic formula, is this x equals -1 plus the square root of 29 over 2, or x equals -1 minus the square root of 29 over 2. And of course, we have x equals 0 or this or this. Notice a couple of things that as before, when we had a cubic equation, for example, this one, we got 3 solutions. Okay, by cubic equation, I mean one with an x cubed out in front of it. Okay, this equation is the same as this one, and there are our 3 solutions. Okay, so when it looks like this with an x cubed out in front, there will be 3 solutions. Here, abbreviating everything that we did up to this point, we see that there are 3 solutions. Okay, so our solution set -1 plus the square root of 29 over 2, -1 minus the square root of 29 over 2. This is a solution, and this is a solution, and this is a solution, assuming I did my arithmetic right. Okay. Now I'll mention that if you got, this is a plus 7x, well, that would have given you a negative 29, well, a negative 27 under the radical. Okay. If you get a negative under the radical, it's not a real number because you can't take the square root of a negative and get a real number. Okay, square root of a negative is not a real number. Square root of a negative is an imaginary number, but we're not talking about that just yet. So everybody should have seen that in their prerequisite courses, but a lot of people don't necessarily remember it. Maybe some people didn't even see it. And actually, this being an intermediate algebra course, there's a pretty good chance that people really wouldn't. No, this isn't intermediate algebra. Yeah, this is intermediate algebra. Okay. Gotta remember where I am. Sorry. Okay, well, that's it. Now I've moved the assignment on quadratic functions up to where it's due on Monday. Okay, if you know how to plug in, and you can read the examples and so forth, you'll pick up a little bit more about it, but that's really basically what it is.